series on computer graphics. In today's video lecture, we will be discussing about digital differential analyzer algorithm. In short, it is called as DDA algorithm. So what is this DDA algorithm? So this is called as a line drawing algorithm. Called as a line drawing algorithm. This algorithm is one of the popular algorithm, and this is also called as a fundamental algorithm. Line drawing algorithm, this uses a raster scan approach. This algorithm uses a raster scan approach to draw a line. So what is a raster scan approach? So to draw a particular image in a computer screen or in a CRT, an electronic beam, say for example, I want to draw a particular object. Say for example, this is called as a CRT screen here. Now I want to draw a particular object called as 1. So I have a beam like this. This is called as electronic beam, and to make 1, so this pixel should be visible, this pixel should be visible, and this pixel should be visible. And these are called as horizontal lines, are called as electronic beam. So wherever you want to draw, that pixel will be on. So this pixel, all these pixels are in off state, and this pixels, wherever I have draw a simple object called as 1, this is called as on state. So the pixel will be on only in the selected areas. That's why it is called as raster scan approach. This algorithm uses a raster scan approach. And this algorithm also uses an incremental approach. Incremental approach to draw a line. So what is incremental approach? Let us assume that I have a graph like this, which have x-axis and y-axis. I want to draw a line from point P1. Let us assume this is called as point P1, and I want to end it up in P2. And point P1 has a coordinates called as x1, y1, and point P2 has coordinates called as x2, y2. I want to draw a line from P1 to P2. Now you have two coordinates, x1, y1 and x2, y2. There are two coordinates, but a line is drawn from P1 to P2. So these 2 points is not sufficient to draw a line. So you should require more than these points to draw a line. So what we have to do? Now from P1 to P2, there are so many points in between. For example, so this point, let us assume that this is T1 and this is T2 and this is T3. So let us assume there are 3 points in between T1, T2 and T3. What is this incremental approach? So to get a point called as T1, you have to use the point called as P1, a point before that. So before T1 there is a point called as P1. And if you want to get T2, you have to use the point called as T1. And if you want to get T3, then you have to use the point called as T2. So for calculating every xi plus 1 point, you need x of I point. That means a point before that. To calculate to calculate xi plus 1 point, you use x of I point. So that's why this algorithm is called as an incremental approach algorithm. And this algorithm is also called as a vector generation algorithm. It's also called as vector generation algorithm. Algorithm also called as vector generation algorithm. Now, the basic drawing scenario is you get 2 points. You should know how to make this algorithm work. Now, you get 2 points. Accept, the first step is accept 2 points x1 comma y1 and x2 comma y2 for drawing a line. Whereas here x1 comma y1 is called as a starting point of the line, and x2 comma y2 is called as the ending point of the line. So line starts in x1 y1 and it ends in x2 comma y2. Second step, you have to calculate the slope of a line is given by m equal to y2 minus y1 divided by x2 minus x1. So this slope is actually this area. M equal to y2 minus y1 divided by x2 minus x1. Suppose if this m value, before going into that you have to know what is the line drawing equation. So line equation is given by y equal to mx plus b. M is called as slope, so which we have already given the formula here, y2 minus y1 by x2 minus x1, and b is called as y-intercept. B is called as y-intercept. Okay, what is y-intercept? So when you take up this line, suppose if this line intersects with y, then it is called as y-intercept. Suppose if this line intersects with x, then it is called as x-intercept. Okay, and this is called as a line equation. Now you can compute m equal to y2 minus y1 by x2 minus x1. Suppose you should know set of conditions, case 1. So case 1, if m value is less than 1, then x of I plus 1 is calculated as x of I plus 1 and y of I plus 1 is calculated as y of I plus m. This is for case number 1. If m value is actually less than 1. Suppose if the case is other way around, see for example, for instance, if in case 2, if m value is greater than 1, that means the value of y is greater than value of x. That means the difference of y is greater than the difference of x. Then obviously m value will be greater than 1. In that case, what you have to do is x of I plus 1 is equal to x of I plus 1 by m, and y of I plus 1 is equal to y of I plus 1. Suppose we have a case 3. Say for example, case 3. If both are equal, that means if m is equal to 1, then x of I plus 1 is equal to xi plus 1, and y of I plus 1 is equal to yi plus 1. Okay. So we will proceed in this fashion until the value x or y is equivalent to the destination point called as x2, y2. So this algorithm is repeated until you get a point which is equivalent to x2, y2. Welcome back again. Now we will draw an algorithm, use an algorithm to draw a line from 2, 5 to 7, 7. We will be using this algorithm. So to draw a line, first you have to calculate the value of m here. So what is m? You know that m is called as y2 minus y1. So what is y2? It is 7. y1 is 5. And x2 is 7. And x1 is 2. Now when you just divide 2 by 5, so obviously this value is 0.4. So this value is called as 0.4. Now what the condition states in the previous lesson, if m value is less than 1, then you have to, if m value is less than 1, then you have to increment the value of xi by 1 and yi by m. So we will be applying this formula in the line drawing algorithm. We will first plot x, y with this algorithm. Now to draw a line from, you have to need a set of coordinates here. So we will be using this DDA algorithm to find out the coordinates, subsequent coordinates from xi to x to the power of n, xi to xn. Okay. Now iteration, first we will make it as iteration 0. So iteration 0 and plot of round of x, round of y. So whatever the value which is given over here, it should be rounded. So what is meant by round? Say for example, if I have 4.6, then it should be rounded to the nearest whole number, it is 5. Suppose if I have 4.3, okay, then it should be, when it is rounded, it should be 4. Okay. So whatever value you have over here, it should be rounded off. Suppose if it is 4.5, then it should be rounded to 5. I'll do it. The first number point, that is x1, y1 is 2, 5. When you round it, you will be getting the same answer called as 2, 5. So we'll make 2, 5. So iteration 0 is called as I here, xi plus 1. So since the value of slope is less than 1, value of x should be increased by 1. So what is the value of x? X is called as 2. So it should become 3. And what is the value of y? Y value is 5. So y value has to be incremented with the value of the slope value. Slope value is 4.4. So 5 plus 0.4, it should be 5.4. So I'll go for iteration 1. So value of x is 3 and 5.4, when you round it off, it should be 5. Yes. I'll go to the next one. As usual, x will be incremented by 1. So x value will become 4, and when you take this 5.4 add with 0.4, it will become 5.4 plus 0.4 will become 5.8. I'll go over here, go to the iteration 2. When you round it off, the answer will be 4 and 5.8 will become 6 here. And again x will be incremented by 1, so it is 5, and 5.8 added with 0.4 will become 6.2. And iteration number 3, when you round it off, 5, 6.2 will become 6, and next iteration 5 will be incremented by 1, that will become 6, x value will be incremented by 1, it will become 6. Then 6.2 when incremented by 0.4, it will become 6.6. Go for iteration number 4. So when you round it off, 6.6 will become 7, and 6 will become again 7 when you increment the value of 6 by 1, and 6.6.4 it will become 7.0. So we will go for iteration number 5. 6 will become 7 and 7.0 will become again 7. So 7, and 7.0 when 0.4 is incremented for this value, it will become 7.4. So now, sorry, this 7 should become 8 here. And 7.4. So when you take it up, almost we have exceeded the points. So what is the source point here? Source point is 2.5, that is the starting point, and the destination is 7, 7. So we have already got the value 7, 7 in the iteration number 4. So up to this we can stop it here. So we can draw the line from iteration number 0 to iteration number 4, because since we have reached the destination point, there is no need to calculate further. So this is the actual coordinates which were line drawing algorithm. So line drawing algorithm has its own drawbacks and advantages. The advantages, it is advantages of line drawing algorithm, that is DDA algorithm. It is a simple algorithm. It is simple algorithm. So no special skills is required to draw this algorithm, use this algorithm. Number 2, it is a faster method. It uses a faster method than using the line equation. So what is the line equation? Y equal to mx plus b. We have already given the illustration of mx plus b. Now, disadvantages. So disadvantages of this line drawing algorithm: it uses a floating point arithmetic. It uses a floating point arithmetic. And since it is using a floating point arithmetic and time consuming, so it is time consuming. This algorithm is time consuming. Number 2, and the algorithm is orientation dependent. It is orientation dependent. It is orientation dependent. So accuracy is poor. So point accuracy is poor. So accuracy in the sense which actually in this context denotes the point here. So point accuracy is poor. So that's all about this algorithm. Thanks for watching the video. Have a good day.